Let's begin with the first question. What is the SI unit of resistivity? Resistivity is given by rho. Rho is equal to RA divided by L, where the unit of resistance is ohm, unit of area is meter square, and the unit of the length is meter. When we cancel, we get ohm meter. So the SI unit of resistance is ohm meter. Ohm centimeter is given, ohm is given, and none of the above. The correct answer is ohm meter. Next question. Resistivity changes with change in time, temperature, heat, area of cross section. See, resistivity, we know resistance depends on the length, area, nature and temperature of the material, whereas resistivity will depend on only the nature and temperature of the material. So here, not the time, not the heat, not the area of cross section, but temperature. So resistivity changes with change in temperature. This is the correct answer. Next question. Dash is used for electrical transmission line as it has low resistivity. Option A is copper, option B is aluminium, option C is both A and B, option D is none of the above. Copper as well as aluminium both are used in the transmission line because it has low resistivity. Okay, you can find that roadside overhead lines are made up of aluminium wire, aluminium core steel reinforced wire, and in the house wiring we find that copper metal is used for transmission of electric power. So the option would be option C, both A and B. Fourth question. Electrical resistivity of a given metallic wire depends on its length, thickness, shape and nature of the material. I already discussed that resistivity depends on nature and temperature of the material. Here the given option is nature of the material, so therefore D is the correct answer. A cylindrical conductor of length and uniform area of cross section has resistance R. What would be the area of cross section of another conductor of length 2L and resistance R of the same material? Here, what would be the area of cross section? That means, how do we write area from resistance? We know resistance R is equal to rho L by A. Okay, and area, we can write area from this as rho L by R. Okay, so now if the length is doubled, see the length is doubled, what will be the area of cross section? Resistance remains the same, okay, only the length is doubled. So when the length is doubled, we can replace this L dash by 2L, so we get 2L rho by R. okay, which means area is doubled. The new area, that is going to be doubled. So 2 times of the original area. The new area is going to be the 2 times of the original area. Okay, so answer is 2A. Resistivity of conductor increases with increasing of the temperature. That's right. When temperature increases, resistivity will also increase. The resistivity of conductor. Okay, conductor means metals and alloys. You can consider alloys also. See, reason is resistivity is reciprocal of conductivity. Resistivity is reciprocal of conductivity is right. Resistance increases with increase in temperature also right. But resistivity is reciprocal of conductivity won't be the correct reason for the assertion. Okay. So resistivity is reciprocal of conductivity is not the correct reason for the assertion. So option must be B. Both assertion and reason are true, but reason is not correct explanation of assertion. Okay, so option B is the correct answer. 7th question. Copper is used to make electric wires. Yes, that's right. Reason is copper has very low electrical resistance. Yes, copper has low resistance as well as resistivity. Okay, so it is a good conductor. That's why it is used in electric wires. So both assertion and reason are true, and reason is the correct explanation of assertion. So it must be option A. A is the correct answer. Assertion. Silver is not used to make electric wires. Yes. Have you seen that the silver wires are used for electrical power transmission? No, because it is costly and it will oxidize at high temperature. So these are the two reasons. But the reason given is silver is a bad conductor. No, silver has got low resistivity. It is a good conductor only. Though it is a good conductor, it is not used for electric wires because, as I told, silver is costly and it will oxidize at high temperature. So assertion is right, reason is false. Assertion is right, reason is false. So option C is the correct answer. Ninth question. Why are the heating elements of electric toasters and electric irons made of an alloy rather than a pure metal? See, alloys, why do we use alloys rather than a pure metal? Because better than the pure metal, the alloys will be having good resistivity. Okay, you can find that the toasters and irons, the alloys which is used have got high resistivity and high resistance. Okay, option B is the correct answer. Due to high resistivity of alloys rather than its constituting metals, we use alloys rather than pure metal for electric heating purpose. See, if it is having low resistivity, no, and a low melting point, no, that can't be used. So always you should know that the wires which is used for electric toasters and electric irons oven, yeah, so they are all made up of high resistivity and high resistance and high melting point. Okay, they should have all these characteristics. 10th question. Write SI unit of resistivity. See, we have seen that the resistivity is given by rho. Rho is equal to RA by L. So the unit of resistance is ohm, unit of area is meter square, and unit of length is meter. So if we cancel meter square and meter, we get ohm meter. Ohm meter is the SI unit of resistivity. Ohm meter. Ampere second, ohm second, ampere meter, these are all the wrong units. The correct answer is ohm meter. What is electrical resistivity? Electrical resistivity of the material of a conductor is the resistance offered by the conductor of length 1 meter and area of cross section 1 meter square. And let us see B option. Rate at which energy per hour is consumed is called electrical resistivity. Energy per hour. No. See, energy per time, it's going to be what? It's power. So it is not electrical resistivity. So this is wrong answer. 1 coulomb of charge flows through a cross section of conductor per second. Coulomb per second, it's what? It's ampere. No. And none of the above. No. So the correct answer is this. We know that R is equal to rho L by A. And from this resistivity, when we write rho is equal to RA by L, when we have the resistance as R and the area 1 meter square and the length 1 meter, so when we substitute 1, we get rho is equal to R. So we can say electrical resistivity is the material of a conductor is the resistance offered by the conductor of length 1 meter and area 1 meter square. Okay, so the right answer is option A. So when we have meter cube of a material, the resistance offered between the opposite edges, say for example this and the opposite surface, this surface and this surface. So the resistance offered between these two is said to be specific resistance or resistivity. So when the area and the length is going to be 1, area is 1 meter square and length is 1 meter. Okay. List the factors on which the resistance of a conductor in the shape of wire depends. See, the resistance depends on length, area. Yes, we know that the formula for resistance is directly proportional to length and inversely proportional to area. So it is dependent on A and B. So therefore, option C, all of these. Why are metals good conductors of electricity whereas glass is a bad conductor of electricity? Give reason. See, metals have got low resistivity whereas the glass have got high resistivity or high resistance. It will not allow the current to flow. That is the case of glass. Whereas metals are good conductors because they have got low resistivity as well as they have free electrons. Okay, so the option must be option D. Metals are good conductors. Reason is they have low resistivity and free electrons. Both A and C is the correct answer. Why are alloys commonly used in electric heating devices? So as it already told you that the alloys which are used for electric heating purposes should have high resistivity, high melting point and do not oxidize at high temperature. So all of these is the correct answer. 15th question. Go through this table and answer the following questions. Which among iron and mercury is the better conductor? Just see, iron has got 10 into 10 to the power minus 8, whereas mercury is 94 into 10 to the power minus 18. So which has got low resistivity? That will be better conductor. So iron has got less resistivity, so therefore iron is better conductor. Correct answer is iron. Study the table and answer the following question. Amongst iron, silver, nichrome, tungsten, which metal alloy should be used to make the heating element of electric geysers? As I already told, for boiling or heating element, iron, just compare and see. Iron is 10, silver is 1.6. Okay, silver is 1.6, iron is 10, then nichrome is 100, and tungsten, yes, it's 5.2. So which has got high resistivity? Nichrome. So nichrome 10 to the power minus 6, 100 into 10 to the power minus 6. So this nichrome has got high resistivity. So for heating elements, for heating devices, the elements used must have high resistivity. So which is having high resistivity? Nichrome. So the answer C is the correct answer. Study the above table and answer the following questions. Amongst iron, silver, nickel, nichrome, tungsten, which metal or alloy should be used to make filament of incandescent bulbs? It's tungsten. Okay, so for filament of incandescent bulb we use tungsten, 1.5 into 10 to the power minus 8. That's right. Study the above table and answer the following. Why elements of electrical heating devices are made up of alloys? I told you that it should have high melting point and high resistance, and it does not oxidize at high temperature. That's the reason they are used. So option must be all of these. In the above table, electrical resistivities of some substance in ohm meter at 20 degree are given. Answer the following questions with the reference to the above table. Out of the silver and copper, which is the better conductor of electric current and why? Silver and copper. Just see, silver 1.60 and copper is 1.62. Copper has got a little higher resistivity, which is lower resistivity silver. So the better conductor of electric current would be silver because it has low resistivity. Okay, option E is the correct answer. In the above table, which substance is preferred to be used for electrical transmission lines? Silver, copper, tungsten, mercury, iron, nichrome. So it must be copper, because copper is economical. Economical means cost is less. It is less expensive and has got low resistivity. We can't use silver because it is expensive. Okay. Iron, because it has comparatively higher resistivity. No. Nichrome, no. Highest resistivity, no. None of these. Answer A is the correct answer. Okay. Which of the following factors do not affect resistance? Length is, of course, resistance depends on length. Temperature, nature of the material, yes, but not on color. So the factor which does not affect the resistance is color. Option C. Next question. Conductor have very low resistivity. It's true. Option A. It's true. A fuse wire is a wire of low resistance, low melting point. If it has got low resistance and low melting point, no, this is not the correct answer. High resistance and low melting point. Low resistance and high melting point. High resistance and high melting point. It should have low melting point because it has to protect the equipment from damage, no? So it has to open the circuit, so therefore low melting point. That's right. So it must be option A and B, but A cannot be. B is the correct option because a fuse wire should have high resistance and low melting point. So option B is the correct answer. State true or false. A fuse wire is a safety device which melts when current flows through it. Is less than expected value. No. So when the current flowing through the fuse wire is less than the expected value, then the fuse doesn't melt and it does not protect the equipment from damage. So it must be higher than the expected value. Only then it will melt. Okay, so it is false. Under which of the following conditions the resistivity does not change? Material is changed. Resistivity depends on material and temperature. So it is neither option A or B. So shape of the resistor is changed. It doesn't affect. Both material, temperature are changed. So both material and temperature are changed, then it is going to affect the resistivity. So the option must be option C, which does not affect the resistivity. That means it does not change resistivity when the shape of the resistor is changed. That's right. Assertion and reason type question. Tungsten metal is used for making filaments of incandescent lamp. Yes, it is made of tungsten filament, that is the incandescent lamps which are used in house. It is made of that. Why do we use the tungsten filament? Because it has got high melting point. Okay, that must be the reason, but the reason given here is melting point of the tungsten is very low. No. So assertion is true, reason is false, and it is not the correct explanation of assertion. Okay, so assertion is true, reason is false. Which option? Option C. Assertion is true, reason is false. So option C must be the correct answer. Okay, option C must be the correct answer. Longer wires have greater resistance and smaller wires have lesser resistance. Now, longer wires will have greater resistance. Yes, correct. Because as the length is increasing, the resistance will also increase, and smaller wires will have lesser resistance. That's true. And resistance is inversely proportional to the length of the wire. No, it is directly proportional. Okay, so the reason is wrong, but assertion is true. So it must be option C. Reason is false, assertion is true. Option C is the correct answer. Alloys are commonly used in electrical heating devices like electric iron toasters, etc. Yes, we use alloys. That's true. Alloys do not oxidize easily at high temperature. Yes, the reason is correct. It doesn't oxidize at high temperature. It has high melting point and high resistivity. So option A is correct. Both A and R are true, and R is correct explanation of A. Option A is the correct answer. Here in the figure, at which temperature the resistance is higher? So you know the slope of this and slope of this when you take. So here V is going to be more. V by I ratio, V by I ratio, that is going to be resistance. So this V by I ratio is going to be more. So therefore this R2 resistance will have higher resistance. That means the slope, that is the resistance having the slope, this one, first one, it's going to be R2 is going to have higher resistance. Okay, resistance and temperature, they are dependent, they are directly proportional. If the temperature increases, resistance also increase in case of conductors. Okay, so option T2 is the correct answer. T2, that means yes, resistance R2. Which of the following are the special features of the heating wire? So heating wire, I told that it must have high melting point, high resistance, high specific resistance or resistivity. Okay, so both the option A and B are true. They are correct. What happens to the resistance of a wire if it is made thinner? See, if the resistance of the wire is made thinner, the area decreases, so resistance will increase. So option must be A. A option is the correct answer. Which substance is used for making resistance coil of electric heater? Platinum? No. Gold? No. Nichrome? Yes. Silver? No. nichrome is an alloy which has high resistance and high melting point. So it's an alloy, so we can use nichrome. So read the data which is given carefully, and also it is given that the resistivity of the copper is lower than that of the aluminium, which in turn is lower than that of the tungsten. Which of the wire has maximum resistance? See, we know the relation R is directly proportional to length and inversely proportional to area. So here in this case you can find that when the length is increasing, resistance will increase. When area is increasing, okay, resistance will decrease. So when area or the diameter decreases, resistance will increase. So this is the relation. So by knowing this relation, we have to find which wire has got maximum resistance. Maximum resistance 3L. See option, the third wire, you can find that the third wire has got 3L. That means the length is increased by L and diameter is decreased by 2. But when we consider 3D, L by 2, so it's less. So we need to take the highest length. So greater the length, greater will be the resistance. So option C is the correct answer. Greater the length, greater will be the resistance. Here in this problem, which of the wire has minimum resistance? Minimum resistance means area should be less, isn't it? We know that area should be, minimum resistance means area should be more, so that the resistance will be less. Area should be more, thickness should be more. Which has got more thickness? Here the diameter 4D, okay, and the length is decreased. Okay, by decreasing the length, what happens? Resistance will also reduce. So option F will be the correct answer to get the minimum resistance. Option F. 15th question. Resistance of metal wire of length 5 meter is 100 ohm. If the area of cross section of wire is 3 into 10 to the power minus 7 meter square, what is the resistivity of the metal? So here let us see what all the data is given. Length is given, right? Length is given. Then resistance is given 100 ohm. And then area of cross section is given 3 into 10 to the power minus 7 meter square. And resistivity is that we need to find. So how to find resistivity? What is the formula? We know resistivity is equal to RA by L. Okay, we know R is equal to rho L by A. From that we can rearrange and write RA by L. So now you substitute the value of resistance. Resistance is 100 ohm. So 100 into area is 3 into 10 to the power minus 7 divided by, what is the length? Length is 5 meter. 5. So you cancel this 5 and 100. 20. 23s are 60. So I can write 6 into 10 into 10 to the power minus 7. 60 can be written as 6 into 10, right? So now what is 10 power 1 into 10 power minus 7? That is 6 into 10 to the power minus 6. So the option is B. 6 into 10 power minus 6 ohm meter will be the correct answer of resistivity. Next question. 16th one. In the above image, there are 3 cylindrical copper conductors along with their face areas and length. Which conductor has the highest resistance? So you should know the relation that resistance is directly proportional to length and inversely proportional to area. So when the length is increasing, resistance will increase. When the area is decreasing, resistance will increase. See here, in this first case, we find that area and length is A and L, area of cross section, and the length is the same. So go to the figure B. There the length is doubled and area is halved. See, when we make length doubled and area halved, what happens to A by 2? So it will become 4L now. So here resistance is going to become 4 times of rho L by A. Okay, 4 times of rho L by A. That means the new resistance is going to be 4 times of original resistance. So resistance is increased. So in which case, in option, that is in the figure B. What about in figure C? Length is halved. Length is, when length is halved, what happens? When length is halved, even the resistance will be halved. So resistance will decrease, no? So therefore, this is not the correct conductor. So which is the conductor in which the resistance will be more? Here. Option A is the correct answer. 17th question. In the above figure of VI graph, the metal wires X and Y at a constant temperature is shown. Assuming that the two wires have the same length and same diameter, which of the two wires have higher resistivity? Resistivity is nothing but the resistance when the area is 1 meter square and the length is 1 meter. Okay, so among this, so before that, let us see what will be the slope of this graph. So slope of this graph is going to give you delta I by delta V. Delta I by delta V is going to be conductance. Okay, so which has got the more slope? X has got the more slope. So that means here the slope of this curve, if we take, that will be conductance. Which wires has got more conductance? X has got more conductance. Okay, X has got more conductance and Y has got less conductance. That means, what is conductance? It is reciprocal of resistance. That means they have asked which has got higher resistivity. That means higher resistance. So if you want to get higher resistance, means then the conductance will be less. So which has got less conductance here? Y. So therefore Y wire is going to have higher resistivity. Option A is the correct answer. 18th question. The specific resistance of the material of the wire is 44 into 10 to the power minus 8 ohm meter. If the resistance of the wire is 14 ohm and its diameter is 1 millimeter, what is the length of the wire? So here resistivity is given 44 into 10 power minus 8. Resistance is given, that is 14 ohm. Diameter is given, we can find the radius from that. Radius is equal to diameter by 2. So which is 1 millimeter, means it's going to be half into 10 to the power minus 3. Half into 10 to the power minus 3 meter. Okay, that's going to be the radius. So now we need to find the length. So how to find the length? So we know the formula, R is equal to rho L by A. So from this we can get what is L. L is equal to RA divided by rho. So now substitute. R is how much? 14. And what is A? Area of cross section, 44 into that is, here in this case it is area of cross section. For finding the area of cross section, see here, when we take a wire, the area of cross section is going to be pi r square. So here we write pi. Pi is 22 by 7, okay, into r square. R value is what? 1 by 2 into 10 power minus 3. Whole square is going to be 1 by 4 into 10 to the power minus 6. Okay. So area of cross section we have done. We have written. And what is rho? Rho is 44. So 44 into 10 to the power, I'll put 10 to the power minus 8 here. Okay, 44 into 10 power minus 8. So now 44 and 22 get cancelled, 2 here, and 7 and 14 get cancelled, 2 here, 2 and 2 get cancelled, and we have 1 by 4. 1 by 4 is what? 0.25, okay, into 10 power minus 6 divided by 10 power minus 8 is going to be 10 power 2. Okay, so 10 power 2 means it's 100. So 100 into 0.25, it's going to be 25 meter. So option A is the correct answer. Which has less electrical resistance? So we have seen that resistance is directly proportional to length and inversely proportional to area. So area gives the thickness. So if the thickness increases, area, that is thickness in the sense area, if the thickness or the area is increasing, then the resistance will decrease. Less resistance means thicker wire will have less resistance. Option B is the correct answer. Which has more resistance? So we know that resistance is directly proportional to length. When the length is increasing, resistance will also increase. So more resistance is the long piece of nichrome wire will be the correct answer. How does the resistance of a pure metal changes if its temperature decreases? See, I told you that the resistance is dependent on temperature. Resistance is dependent on temperature. Okay. So as the temperature increases, the resistance will increase. When the temperature decreases, resistance will decrease. So here the resistance will decrease with the decrease in temperature. Option B is the correct answer. How does the presence of impurities in a metal affects its resistance? See, if the impurities are more, then the resistance will increase. It will affect the resistance, right? So the resistance of the wire increases as the length increases. We know there it is directly proportional, no? So length is directly proportional to resistance, or the resistance is directly proportional to length. As the length increases, resistance will increase. So resistance of the wire increases with the increase in length. Option A is the correct answer. Resistance of the wire increases as the cross-sectional area decreases because they are inversely proportional. What is the resistivity of the silver at 20 degrees Celsius? It's 1.60 into 10 to the power minus 8 ohm meter. And 1.69 is going to be for copper. Even silver and copper has got little difference. So you have to remember that. What is the resistivity of the copper at 20 degrees Celsius? It is 1.69. A little higher resistivity when compared to that of silver. Copper has a little higher resistivity than compared to that of silver. It is 1.69 to 10 power minus 8 ohm meter. What is the resistivity of aluminium at 20 degrees Celsius? It's going to be 2.63 into 10 to the power minus 8 ohm meter. Option C is the correct answer. What is the resistivity of the tungsten at 20 degrees Celsius? Tungsten has got high resistivity. Because of that, it is used in electric bulbs, as used as a filament in electric bulbs. Fine. So option D is the correct answer. What is the resistivity of the nichrome at 20 degrees Celsius? We know that nichrome is used in electric oven, electric iron toasters, and all these things. Okay, in the heating element. Why do we use that? Because it has got high resistance, high resistivity, high melting point, and it does not oxidize at high temperature. So option D, it has got high resistivity, 110 into 10 to the power minus 8 ohm meter. Fine. So the next question, what is the resistivity of silicon at 20 degrees Celsius? The resistivity of silicon is going to be 10 to the power 10 to 10 to the power 14 ohm meter. That is the resistivity of silicon. Okay. Silicon is a semiconductor. I have discussed various objective type questions on factors on which resistance depends and resistivity or specific resistance. If you like the video, kindly click the like button and share to all your friends. Please subscribe my channel to get the notification for the upcoming videos. Thank you.